Hello, dear colleagues. First of all, I'd like to say thank you for coming to my presentation despite the perfect weather and warm sea outside. In my presentation, I would like quite traditionally share with some of the most recent changes happening over the past 12 months in our company, and usually I start up with an update and say the news is, but many things have changed in the morning today, because when I looked at the agenda, that half of my report was told by Mr. Choi and the second half was told by my colleagues from Airbus. So I had to change everything quite drastically. And what really happened, what new and significant happened over the past 12 months. First of all, Airbus launched Spot 7 satellite, just like its twin brother Spot 6. We have exclusive rights for it in Russia, and as soon as the flight testing is over, we'll be able to perform imaging with 1.5 meter resolution even more frequently, owing to all our receiving station in Russia. Also, in the beginning of the year, together with Satrep company, the Korean operator, and jointly with the Korean Aerospace Institute Korea, we, for the first time in the world, did the test flight on our own receiving complex for COMSAT 3 satellite. And we came to a conclusion that even for the antenna of 2.5 meters, we can receive it with 5 degrees with no problems, which will help us in future to receive data with the resolution down to 0.7 meters. A multispectral band with many positions could be unique, and we can do it very operationally in real time. Now, our network of stations, many people are aware of this. We already are receiving data from Spot 6, and soon we're going to receive data from Spot 7 and many other spacecraft. And in the future, we'll offer modernization of all our complexes. So far, there are a total of about 8 receiving stations in the world from all the above mentioned satellites: Spot 6, 7, COMSAT 3, and in future COMSAT 3A, COMSAT 5 radar, and everything is being tested. Only COMSAT 3 has been fully tested out of the Korean satellites. And yet another event I would like to mention here is that in April this year, we have launched our private, I'd say, spacecraft, which was developed by our sister company SCANEX. We wanted to establish a small satellite for 25 kilograms, and this platform is being tested. It was launched in April. Now we're receiving its telemetry, we're testing its stabilization and orientation. For the future, we're going to install a well-tested sensor in the camera and launch something like a micro satellite constellation with 1 per day revisit time. This has been mentioned by other people aside from the Aurora launch, maybe. That is why I turned my report towards software. That is our product for telemetric processing of space images. We could say that over the past few years the program has been qualitatively upgraded, and it now enjoys and offers many new functions. Everything is almost fully automatic. The program has modular configuration. It consists of basic modules and additionally a module of radar images, then the module of building digital terrain model and digital elevation models, module for climatic modeling, and internal programming language which can help us establish different scripts and processings. This program was initially developed for our internal needs, because the projects on image processing are multiple numerous, and this is a full production system. This is not a research package like many similar projects elsewhere. It doesn't contain functions which can be used only once in a lifetime just to test it. These are really all the functions that people need on a daily basis, like author correction, mosaic building of digital terrain models and digital elevation models, and so on. Now I would like to know that as long as we work with huge volumes of data, the program has been adopted for such volumes. We denied we don't want to use 32-bit versions. We maintain or we're compatible only with a 64-bit version. If we have any computer, even a laptop, will be using 99% of its capacity. Even at a laptop, we can be even more productive with similar systems established on more serious working stations. And multiple functions from spectral transformations like linear regressions, transformation from one color space to another, pen sharpening by 3 or 4 different methods, and naturally for each type of data some unique method will be more applicable. Some method is better for super high resolution, other for medium resolution, and so on and so forth. Naturally, there are many capacities for geometric rectification of data, like tying two ground control points, ortho transformation based on polymer coefficients, RPC, also polyfill and polymial transformations up to the power of 5, and establishment of tonally balanced mosaics for large areas. Like if we have a block of images, building a mosaic is a fully automatic process. Also automatic vectorization within a certain brightness range, automatic vectorization of the results of classification, and neural network algorithms for interpretation and analysis of the image. Besides, everything is related to the basic module without any additional things. It also has many additional things, like 10 algorithms for classification of the image, like Mach Center algorithm, classification with trees, binary classification, many other things. Raster calculator, which helps us build matrices for various indices, DVI, VI, and others. Where you just insert the formula, you create a dialog window and can call up this program anytime you want. Another thing that nobody is surprised with is thematic products based on these modules, and you don't need to upload the image. You can just put a tick on what products should be uploaded. It could be the temperature of the underlying layer, temperature of clouds, and whenever it is uploaded, it will recognize what needs to be uploaded or not. Compensation of the haze on the image. To your left, you can see an image with a haze, and to the right is the result of the processing. For thematic interpretation of these images, with specialized algorithms, they will not fit after such transformation because spectral characteristics are altered. But for visual analysis, to use it as a background layer, it is quite a useful instrument. Other different algorithms for an automatic detection of changes in the area. If we have 2 or more multi-temporal images, by pressing single button you will see where there are more changes and less changes. You can do it very easily. There could be different applications, like for instance analysis of loggings. If we launch a program and identify the contour forest, and within this contour we start an algorithm, it will show all the changes in the woods, and we split it into classes and look at where it has been overgrown or where the trees have been cut, and many other things. Whatever I'm going to show you now is about basic module. This is part of the actual program. Besides, there are 6 additional things, and this one is one of the more serious tools for our images, like among other controlled or non-controlled classification, which is part of our basic package. This module implements algorithms based on self-organizing networks, topographic images, and also we have instruments for object-oriented segmentation of images. This is an absolutely different approach, you of course understand. And what can it deliver to us? Using the self-organizing neuron networks will help us identify not only classes but also links between these classes. And the program can draw something like a tree. This is an image for neuron network, and then by classifying the image, we don't need to work with the image itself. We can continue working with the network by painting in different colors, and you will see that each separate branch of this tree will be related to a particular class on the image. And this algorithm helps us better identify and split the transition classes to separate an area where the forest ends and the field starts. So we can clearly draw this picture. An object-oriented approach, it's clear. It's not pixel by pixel, it's when the program itself tries to unite objects, and only after that it unites them into classes. This is not a big red button as many people want to see it. So when you press the button you get the result. No, it doesn't work like this, but this is a maximum number of instruments that an expert can use to get what they want. There are many options how to do this. You can also apply a combined approach when you launch segmentation, for instance, and then the result of segmentation is then launched in the neural network classification, and as a result we have maximum precision of the result of splitting into classes and thematic map as a result. Second module is the module for processing of radar images. We do not have any possibility for interferometry or radar interferometry, because we believe that for that we might use specialized software, and we shouldn't try to do everything until we have gamma, until we have Scarscape. We're not going to interfere with that. We have various filtration algorithms for radar data, specialized algorithm for segmentation built specifically for radar data, and also algorithm for detection of ships on water and oil slicks. Module D is building of digital terrain models and digital elevation models. At the moment we can build them both based on vector data and stereo pairs of scanner images. We can use stereo pair to build the digital terrain model and build digital elevation model later on by removing all the houses module of 3D modeling. Of course, when we have digital terrain model and digital elevation model and image, you can always put overimpose the image on our leaf and then get a 3D. You can put on some moving objects, and using the vector you can extract all standard images like houses, boxes, and so on and so forth. Additionally, this is stored in the internal format. Then we have a free of charge program for viewing, where you can see different atmospheric events, clouds, and so on. And here you can see the comparison with the real picture. The modeling module is something more specific that we have here. In fact, inside we have two sub-modules. Number one is the calculation of the radiation balance of atmosphere, the components of radiation balance, and then hydrograph model. When we model floods, rainfalls, and so on. SDK is an internal programming language that helps us write our own scripts for processing, create a user interface, and put into the main menu and call up the dialog windows, and later use it for processing. So this is similar to macros, but much more advanced. This year we have we received the 4th generation of SCANEX image processor. The 4th generation is about photogrammetric processing of space images. First of all, it was done to increase the performance, to increase the speed of processing, and also some additional algorithms appeared which helped us simplify our life. Like we have additional block for building of mosaics, and this process is now done automatically. Automatically we detect the overlap zones. In those overlap zones the program finds tie points between the images, and then there is an instrument for assessment of precision of finding those dots. You can find all those 500 say dots and find those where there are more errors. You just remove them from the calculations so they don't distort the image, and then start the algorithm for processing. After that there is a tonal balancing, equalization of colors, and it works both for overlapping and non-overlapping images. And then they build the seam lines. The seam lines are built again automatically by the program. You can of course advise on the strategy that it can use, either based on the differences in brightness or gradient. Again, it depends on the types of images, or time of taking the image. If it is different seasons, different times, then it's based on gradient. If it is same flight, then you don't need to use anything, or you can use a combination. If you don't like the suggested line of seam, you can use your own, and the program will be looking for contours along the line and will build its own seam, and as a result we get a mosaic which is stitched quite well. This is an example of how the line of stitch line is done. I don't know whether you see the blue line or not. This is what the program suggested itself. Then you can dilute the borders here, and as a result we get the final product. Ortho rectified, tonally balanced image. Also very serious changes happened in the digital elevation model program, and it of course concerned the considerable increase of productivity and the processing of the model. As I showed before, this image can be built from a stereo pair that we build digital terrain model, and then there are all sorts of algorithms to fill in gaps and the invisible places, and then we can use this model by various editing tools. We can get the relief or elevation by putting up the mask like this. What can we say about the main advantages that we can distinguish in this program? First of all, that will be a high performance rate. Among all the things that we tested, the performance is the highest, and the speed has been increased multifold, really. Like DM is built many times faster now. This module helps us choose a necessary configuration of the program, and it is compatible with most of the popular formats. Also, we are compatible with the Russian resource and Canopus B. Also, we are compatible with the Chinese satellites, GF, XY, almost everything. And this is an ever-evolving product because it is developing not along based on the it is easy to master products. We have many tutorials, video tutorials, and step-by-step instructions. It is a multifunctional product. We have provide 24/7 technical support. You can get in touch with us by Skype or by email, and the price of this product is much lower than similar products elsewhere. It is also one of its advantages as a result. Over the past 2 years, the map of users and distributors has been expanded. It includes Russia, China, India, Nepal, Nigeria, Vietnam, You can see all of it on this map. And the users map and distributors map again is growing. So in words everything sounds nice, but tomorrow we'll be having a workshop here and we'll show how the processing works. Moreover, should anybody have questions, you can come with your own data and we'll show it show how it works based on your data. So we invite everybody for 2 o'clock. Here in this conference room we'll be hosting both theoretical and practical part of the workshop, and that's all I had to tell you today. Hopefully I was within the time frame given to me. Thank you very much. Thank you. Are there any questions? No questions.